Fourth semester, so we'll start syllabus of fourth semester now. We will see the okay. We will have one look at our syllabus. So I think you have second paper that includes the cross coupling reactions. Okay, so cross coupling reaction, olefination reactions. Okay, this type of things are there in your secondary syllabus. Some natural product synthesis. Then stereochemistry. One paper is totally belongs to the stereochemistry. That one is, I think, last paper. Uh, so we'll see what is the included in your fourth semester. Okay, so we will start with coupling reactions. Okay, so in our syllabus, as per according to syllabus, we will go with this um, paper number. So 5402 we will start now, but the syllabus first paper is a 5401 chemistry and natural products. Okay, so we'll tell you what is the distribution of syllabus in between me and Bondway as per paper wise. So currently we will start now this paper CHO 5402 advanced synthetic organic chemistry. Okay, so in that one I will take first chapter transition metal complexes in organic synthesis. Okay, so it's a very beautiful topic, and I like it very much. So palladium, nickel, cobalt, iron mediated reactions, carbon carbon synthesis of carbon carbon single bond formation or carbon halogen bond formation reactions catalyzed by transition metals. Okay, so these are the this is the topic which includes the name different name names, Suzuki, Hake, Sonogashira, Stiller, Fukuyama. All these name reactions comes under this topic. Okay, so this 14 lecture topic I will take, and next second topic I will take of second topic third metathesis. Okay, so groups first third topic and first topic I will take from this paper. Okay, so this is the distribution of this topic this paper in between me and Bodwesa. So remaining all second one this one carbon carbon double bond formation, click chemistry, organoboration, green chemistry, that one will be those lecture will be conducted by RSB in future. Okay, so we will concern to coupling reaction and metathesis reaction. So first one we will start with 5304 5402 transition metal complexes in organic synthesis. Okay, so as we know, we have seen, actually that means you are quite familiar with such types of reactions. Transition metal catalyzed different organic synthesis. Then why transition metal catalyst is important? So that is the question comes in our mind. Always it comes in our mind in organic synthesis. Why we need inorganic metals? Okay, so the thing is transition catalyst is vital to modern drug discovery and fine chemical synthesis. So for which things we need transition catalyst? Some of those pharmaceuticals, that means over if you will take a look at top 200 pharmaceutical products by US volume, here are some examples: Celeprex, Sensipar, and Zingufair. Okay, Zigulair or anti-asthmatic, hormone regulator, and non-steroidal anti-inflammatory drug. So this type of drug synthesis, for synthesis of these drugs. Okay, here if you pay attention, here is pyrazole ring is here. Okay, so for synthesis of such types of different drugs, we need the help of transition metal catalyst. Okay, so and without transition metal catalyst, we cannot go for this synthesis of drug discovery. Okay, and each of these contain, okay, if you will pay attention, each of these drug, you will find that contain aromatic rings and other sp2 hybridized carbon atom. Okay, so this one aromatic ring and sp2 hybridized carbon atom bond in between sp2 hybridized carbon atom. Okay, aromatic ring. Okay, here it's not maybe here you can find aromatic ring and sp2 hybridized carbon atom. Okay, carbon carbon single bond. Okay, so to form this type of bonds, we need the help of transition mechanisms. Up to now, up to here, you cannot see that that we can synthesize direct bond in between aromatic ring and other carbon other sp2 hybridized atom. Okay, direct formation of this bond in between these sp2 hybridized carbon atom and these sp2 hybridized carbon atom, it is rare actually. And this coupling reaction is nothing but to synthesize this carbon carbon single bond in between two sp2 hybridized carbon atom. Okay, or sp2 sp3 sp2 sp3 hybridized carbon atom, or sp hybridization, we can connect sp carbon atom. Okay, like this beautiful reactions we can carry out with the help of transition metal catalyst. Okay, this is the beauty of the transition metal catalyst, that we can conduct such types of coupling reactions. So these are the coupling reaction. This is the word for this reaction. These are the coupling reactions. Okay. Now the thing, transition metal catalyzed reactions are extremely useful for rapidly, predictably, and cheaply forming new bonds between sp2 hybridized carbons, aromatic ring, and thus have become an indispensable part of the modern organic chemistry. A cross coupling reaction in organic chemistry, a cross coupling reaction is a reaction where two fragments are joined together with the aid of metal catalyst. So this is the sentence which is very important. These are the cross coupling reaction in between two carbon carbon atom, and with this help we can synthesize one new carbon carbon single bond in between any hybridized carbon atom like sp2 sp2 sp sp2 sp3 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 also we can do with the help of these transition metal catalyst. Okay, so this is the important. Without transition metal catalyst we cannot make this type of cross coupling reaction. In one important reaction type, a main group organometallic compound of the type Rm, okay, reacts with an organic halide of the type Rx with formation of a new carbon carbon bond in the product RR dash. Cross coupling reactions are a subset of coupling reactions. It is often used in relations. Okay, so we'll see one by one. What is this catalyst, which catalyst we are going to use in coupling reaction, cross coupling reaction or coupling reaction. Catalysts are often based on palladium. Okay, mostly palladium we have to use, we do use, which are frequently selected due to high functional group tolerance. Okay, so we use variety of transition metals to conduct this to catalyze this organic transformation, but out of those palladium is the most frequently used because that has high functional group tolerance. Organopalladium compounds are generally stable. Okay, they are stable towards water and air. Palladium catalysts can be problematic for the pharmaceutical industry, which faces extensive regulations regarding heavy metals. Many pharmaceutical chemists attempt to use coupling reactions early in production to minimize metal traces in the product. These are the heterogeneous catalysts based on the palladium are also well developed. Okay, copper based catalyst. Okay, so our title was palladium, copper, nickel, iron based reactions. So copper based catalysts are also common, especially for coupling involving heteroatom carbon bonds. Okay, so we can make bond not only in between carbon carbon but only carbon heteroatom like nitrogen, oxygen, sulfur. Now, like this also we can, these types of bond also we can make with the help of these transition metals. So what type of another things, another metals? So iron we can use, cobalt we can use, nickel catalyst we can use in such reactions, in cross coupling reactions. So palladium, copper, cobalt, iron, nickel, such types of catalysts that they are more well known or famous for this cross coupling reaction. Okay, so now in our syllabus different reactions, just we have seen that different reactions I have shown you. Suzuki coupling reaction, Stiller coupling reaction, these reactions I have shown you. But what are the reactants? Okay, all these are involving the same type of catalyst. So I have listed here and I have given year of invented those reaction, at what year invented. Reactant, what reactant we can use, reactant with their hybridization of that carbon atom. Okay, reactant A, reactant B with their hybridization of that carbon atom. And so here we can say, here sp coupling reaction we do, here sp2 coupling reaction we can do. Catalyst, what catalyst we can use, here I have listed over here all type, all what catalyst and which catalyst we do use for which name reaction. Okay, some of those we have in our synthesis. Kumada coupling we have Heck, Sonogashira, Negeshi, Stiller, Suzuki, and Hiyama, Fukuyama we have. We don't have Morohoshi coupling, Corehouse, Castro Stephens, Cardiot, Chudek we don't have. Okay, so some of them we have to drop, but pay attention on the other things whatever included in your syllabus. So this table is very important. This reactant I have given, reactant A, reactant B, catalyst I have given, and remark also I have given. What are the reaction conditions needed to carry out this coupling reaction. Okay, so we'll see one by one now. Basic things, we will go for the basic thing. Transition metals changes its oxygen states in situ. Okay, why we do use transition metals? Okay, so because what is the beauty of the transition metals, that transition metals changes their oxygen states in situ, that means in between the reaction. Okay, in that reaction only. So as we know everyone that all three series of transition metals, they do have different oxidations, they present in different oxygen state, like this table, you are quite familiar with this table. So as they do show different oxygen states, that means they can change their oxygen state in between. Okay, they can, vanadium can change from +2 to +3, +3 to +4, or maybe he can go from +4 to +2, or +4 to +3 also. Okay, so that means they do change their oxygen state in between. That means they can change in between the reaction, the oxygen state. That is not the case with s block element or p